Hello everyone. In this video, let's explore a new function of LuBan called Helix. What exactly is Helix? Let's do a quick Google search. 3D printed helix. So a helix is a pair of 3D printed structure, spiral-like structure that can fit into each other. So the inner core can be pulled or pushed into the outer object. A helix is quite fascinating. You can see many videos on YouTube describing how to make a helix structure by 3D printing. And most of these structures were designed in Fusion 360 or a modeling software like Rhino. In this video, we are going to show you how to design a helix structure in LuBan in a few button clicks. Let's open LuBan software. Okay, no. Let me fix the small issue. I might have renamed it. Okay, now the shortcut should work. Let's open LuBan software. And I'll firstly generate a basic structure, the outer object. I've seen many people use frustum, a cone. So I'll probably use a cone as well. So this will be our outer object, the hosting object of helix. The actual helix function is in mesh LuBan. I've tidied up the name of these functions. Now they are sorted by the first letter. Helix is here. The inner structure is the red helix structure. Currently it is a preview, it is not the actual helix structure that you will print. The model size XYZ refers to the gray original object. It can be a cone, a cylinder, or any kind of 3D model like a human head or a building. When you change the size of the model size X, hit the enter key, the semi-transparent hosting object will be modified. So let's set it back to 100. Then the rest of the controls is controlling the shape and size of the red helix structure. Center refers to the center of the helix. The cone base is symmetric, so center 0, 0 is fine. But sometimes you may have irregular shaped object, asymmetric object. So you may want to move the center. For example, if I put 0.2, the helix, the red one, is moved in the positive x-axis by 20%. And you can move y-axis as well. Okay. In this particular example, the intersection will not be fully intersected, so I'll move it back to 0. The center is in the origin 0, 0. Okay. These are the percentage, not the actual coordinate. The next parameter is arm. We have 6 arms. You can reduce it to 2 or increase it to 12. In the algorithm, I can set it to even more than 12. But on the GUI, on the user interface, I only exposed up to 12. So let's set it to 5. Arm width is the thickness of the arm. So I can set it to 2, hit the enter key to update the display. Then the helix becomes thinner. If I set it to 9, it becomes thicker. Okay, so let's set it to 5. Diameter is the diameter of the red helix structure. Currently it is 100, and as you can see, if I set 100, all the arms fully intersect the gray object. If I set it to 80, you will see some examples online. The helix structure do not fully intersect. There is a decent amount of the original object that is unaffected on the outside. You cannot see the helix on the outside. It is only on the inside. So to achieve that, you can change the parameter. The angle of rotation refers to the rotation from the top surface of the helix to the bottom surface of the helix. That's the rotation. And the rotation can be a negative value. So if I enter 20, the rotation will be smaller. If I enter negative 20, look closely. When I hit the enter key, the rotation will be reversed. Okay, so you can input positive as well as negative value. Solid base, this is pretty important setting. As you can see currently, this, if I use solid base, then the helix structure will not penetrate from the top to bottom. Instead, it will leave a gap at the bottom so that the object, the gray semi-transparent object, are not completely separated. For instance, if I set this parameter to 120, then you can see that these arms fully separate the gray object except at the bottom. So because of the bottom, the base, the gray object, when you print it, it is still one object. However, if I set solid base to no, the helix structure will be extended out of the gray object, and in this case, your helix will separate, you will segment the original object into several disconnected parts. That may not be what I want. An alternative approach to making the hosting object connected is to reduce the diameter. Now, and the bottom region are connected even though the base is cut through. So when you have this kind of helix structure, the red one can move up and down throughout the entire object. It will not be stopped. This will be stopped at the base. Finally, the parameter tolerance. If you are an existing LuBan user, you know what tolerance does. Here, the tolerance is very important. I recommend you set a large negative value such as 0.5. Hit the enter key. You won't see the tolerance showing on the preview. So the helix function is a bit different from the other functions. It takes a long time to calculate. So you will see the tolerance, the gap between the red and white, only when you click Save Model. I'll save it on the desktop, and you will see a progress bar. The progress bar only has two status, 1 and 2. For some reason, the functions that I use depends on a third-party underlying algorithm, and the Windows version is extremely slow. Even though the structure is quite simple, it is extremely slow. If you use Mac or Linux LuBan versions, you will find that this function is very fast. However, the Windows version is slow. I apologize for this. So now that this is calculated, and there's a second half to be finished. We have used a coin, and the coin doesn't have many vertices. If you use an organic STL model, such as a human head or a building, this function, the helix save model function, can take several hours to calculate. However, I still think it is valuable to present you this version because you don't have to go through the modeling software to design it. That's the calculated actual helix structure. As you can see, there is a gap, 0.5 millimeter gap between the inner helix and the outer helix. We can press Object, select. Actually, this is not really necessary because the outer one is already semi-transparent. So that's the outer one, that's the inner one. Okay. And let's open the saved model. The model is saved here. You will see there are two objects, helix 1 and 2. Helix 2 is the hosting object. Helix 1 is the inner core of the helix. So these color changing layers, you can ignore it. These are just small defects. I haven't used very fine scale layers, fine scale transitions to simulate the rotation of the helix. The reason that I didn't use fine scale transition is because of the concern of data processing time. If I increase the vertices, then the data processing will be even longer. I'll see how our users print this structure. If they believe there should be finer details of the helix, I can just increase the vertices, so no worries about it. That is it. You can easily create other type of 3D shapes, such as a circle. If you use a circle, go to the helix function and you will get it. So we have a solid bottom. I'm not going to do it because it takes a while. In our example, we used, let me close this. You can also use mesh. You can also use any kind of model to make a helix. So I'll set it to 100. You can use a 3D model as the hosting helix as well. The cowl will be separated into several parts in this case. So in order to make the cowl one body, we have to reduce the diameter. Yeah, this should be good enough. Okay. So that's it. I hope you'll find this function interesting. The drawback of this function on the Windows platform is the data processing time. It is very long, so you have to be patient. As long as LuBan does not close itself, it is processing and it will come back.